because in the winter we found that there was just obviously no light and the solar energy would go and the batteries would drop and we suddenly lose data and think, oh, I've got to go back to Norway again. Just because the batteries have gone, and finally we end up going up there, taking the batteries down to the cabin, charging them up, coming up again, plugging them in and going, oh, is that all we came for? So anyway, the wind generator is very good, nice small thing, and it's actually clamped looking up at the wind. And the wind doesn't really change much, so it generally sits there spinning happily and has survived 2 years out in the ice. So all this is ice, that's frozen lake down there. What does this have to do? Obviously it has to talk to the probes, so we'll go on to that in a minute. It has to have the equivalent of one of these probe radios to talk to the probes. But also, we were trying to do a location system one day where we would measure where the probes were with respect to this by using some very clever technique. So this would obviously move down the glacier. It would move about 10 to 15 meters a year. It's always on the move. So you need to know where this is. So we put a differential GPS antenna on the top. Differential GPS is very different from normal GPS we use. You can measure the distance between this and another point to an accuracy of like 1 centimetre. So that gives you not only where this is, but it tells you how fast the ice surface is moving, because you've got these distances every day. So it's got a radio to talk to the base, which is 3 kilometres away in the cafe. It has a GSM telephone for backup. We thought that was an interesting thing to do. If the radio link to the cafe broke, it would just send text messages with the data in. And we thought, yeah, right, you know, maybe one day, a laugh, good story. But actually one day, I think the antennas or something went really